Okay, so this video will cover the review of the Chapter 2, Quiz 2 practice quiz. And we'll work through each of the problems here. So number one, we're to find the inverse of this matrix. And so the process we do that with is we say 1 over the determinant of the matrix. So this is the determinant, times what we call the switcheroo, or what I call the switcheroo. And remember how that happens is that the values on the diagonal going, just a second here, the values on the diagonal going this way have switched places, and the values on the diagonal going this way have become their opposites. Okay, so the 6 and the 4 switched places, and the -2 and the positive 6 become their opposites. So positive 2 and -6. So then I take the determinant of that matrix, highlighted in yellow, and that is 36, times the switcheroo, and then you distribute that 1 over 36 inside to the matrix. So 1/36 of 4 is 1/9. 1/36 of -6 is -1/6. 1/36 of 2 is 1/18, and 1/36 of 6 is 1/6. And so that's how we find the inverse. Let's go a little bit more in depth on the next problem on how to find the determinant, because there's probably some people scratching their heads on how I went from this to this. Okay, so the next problem will go into more detail on that. So find the determinant of this matrix. Okay, to do that we take the product of these terms minus the product of these terms. Okay, so we have 3 times 7 minus 4 times 5. So 21 minus 20, which equals 1. Okay, so that's the same thing that happened on the previous problem. We had 6 times 4 minus -2 times 6, giving me 36. Over here was the 3 times 7 minus 4 times 5, which gives me 1. Alright, good. Let's go on to the next one. Find the value of the determinant of this 3 by 3 matrix. So this becomes a little bit more involved, and yes, you will have to do this by hand on the test. The calculator, I know it can do this, but I want you to be able to do it by hand. And so the process we do this is we take first, we say, we cross this out like this is how I like to do it, and we have this small matrix here left of 4, 7, 3, 2. So the place where those two lines crossed was at 6. Okay, and I'll show you that again. Okay, so we had a 6 up there. So I've got 6 times the determinant of what's left, the 4, 7, 3, 2. Okay, minus 4. Now this one comes from going, let's see here, move this over 1. That didn't work, sorry. So the next one I take and I do the same thing. Cross that out, and I've got 4, that's where those two lines crossed, times 2, 7, 5, 2, that determinant. And then finally we do 6, because that's where these two lines cross now, times the determinant of 2, 4, 5, 3. Now the place where a lot of people have make a mistake is they forget that first this is subtraction and then this is addition. So subtraction then addition. So then I need to go ahead and find the determinant of each of these matrices that is left. Okay, so this results with -13, and then this determinant results in -31, and then this determinant results in -14. And then it becomes a simple matter of the 6 times -13, the 4 times -31, the 6 times -14, just cranking those out, and we get a result for the determinant of negative 38. All right, moving forward. So this one I've left some work to be done. It says to graph the system of inequalities. So I have my graph here. Now I need to go ahead and graph each of them. So the first one, m plus n, is less than or equal to 24. So that leaves me with an m-intercept and an n-intercept of 24. Okay, so that's going to look like this. And then I need to decide where to shade. And that would be, well, let's test the point 0, 0. So 0, 0, 0 plus 0, that is less than or equal to 24, so it's going to be that side of the line that gets shaded. Okay, and then my other one, I have n is less than 15. Okay, so I go n is 15 where? So that's going to be right here. Oh, almost. My tracking didn't want to work. 15 right here. If I can get the line to line up, sorry. So this is where it's 15. But here's a tricky thing. Because it says it's strictly less than, this has to be a dashed line. So I'm going to go back with my eraser and make this a dashed line because it's strictly less than. Okay? So I'm going to go back through and I make this a dashed line. And now I have to test a value, test 0, 0, and 0 is less than 15, so that's going to be where I shade, is down below. Sorry, my clock is going off in my house here. Let me pause it. Okay, so thank you for waiting there. Should be done ringing. Now the commonly shaded region, I'll go back and make that more clearly identifiable. Alright, so the commonly shaded region here is this portion in here. Okay, this is my commonly shaded region for the system of inequalities. Alright, let's move on to the next one. Again, we have another system of inequalities to graph. This time we have three inequalities to graph. So the first one, this 2x plus y is less than or equal to 14. We have an x-intercept of 7, y-intercept of 14. Alright, so I'm going to need to go from up here at 14 down to 7. That didn't line up so well. Let me try that again. 7 to 14. There we go. Just using my x and y intercepts. That is a solid line because it's strict. Because it is less than or equal to. It is solid. And now I need to test a point, so I will test the point 0, 0. If I put 0, 0 into that inequality, I get 0 plus 0. Is that less than or equal to 14? Yes. So that's the side of the line that I shade. Okay. Now, I'll go ahead and graph the next one. It says x is greater than 4. So I go to where x is 4, and I draw that line. Now this is strictly greater than, so I'm going to go ahead and make this a dashed line. There we go, it's a dashed line. And greater than would be to the right of that. So that's going to be over here. Okay. So far I've got this little wedge down on the bottom that is commonly shaded. And now I've got y is greater than 1. So I will graph that line. That didn't line up quite so well there, but that's okay. And greater than would be strictly greater than, so it is dashed because the line is not part of the solution. And greater than would be above that, so that's going to be up here. Alright, so the commonly shaded region then for this is inside this triangular region. It is in here, so I'll make that a little bit more clearly identified. There we go. So that is the commonly shaded region. That is the solution for the system of inequalities. moving forward. This one I've already gone ahead and graphed. We are to find the maximum value of the objective function f of xy is equal to 3x plus 4y for the system of inequalities which act as constraints. So I have graphed each of those and identified the commonly shaded region. From there, we go ahead and identify the vertices of that commonly shaded region, which are at 2, 6, 6, 4, and -1, -3. And I plug each of those values into my objective function up here at the top. I plug each of them into this. Okay. So when I put the 0.26 in, I get out 30. So 2 goes in for x, 6 goes in for y, it gives me 30. F of 6, 4 is 34, and f of -1, -3 is -15. So my maximum value then is at 34. So I would go ahead and say that we have a max of 34 at 6, 4. Okay, there we go. Last problem. This is a big, long word problem. A lot of things are involved in it. It's a toy shop that makes two different types of vehicles, two different types of toys, sorry, wooden cars and wooden tops. And they are restricted by, the amount of time they have available for woodworking and for painting. Okay, so this problem, as is on the test, will not require you to graph it, as I will give you the vertices ahead of time. So here are the vertices for the commonly shaded region, and I also give you the objective function, as will be the case on the quiz. So now our goal is to maximize this profit equation given the vertices. So we plug each of the pairs of vertices, or each of the ordered pairs in, that are the vertices rather, into the profit equation. And something interesting happens in this one. In this particular case, there is no maximum. Well, there is a maximum of 120, but there's no singular solution. We have two solutions. So we can say there's a maximum profit, max profit of $120 at either what is it, 12 cars and 0 tops, or we would have 0 cars and 20 tops. Either of those would result in a maximum profit. Okay, so we guess we got to pick which type of toy we're going to make. Either cars or tops, but not both. Alright, there you go. I hope this is helpful. I got to wrap things up because my son is going to bed and I can't keep him up too much here. So have fun, good luck, and study hard.